Hello, everyone, and welcome to our webinar, Claude 3 Cookbook, leveraging OCR and multimodal data extraction. My name is Matt Brown. I'll be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars. We do 2 per week, demoing data and AI use cases, new tools, and technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn to stay in the loop. I'd love to hear your feedback on these sessions and also any topics or tools that you want to see in future sessions. Speaking of future sessions, if you click to the next slide, we have an awesome session coming up on Monday. We will be presenting LangChain for multimodal, chat with text and image data. You can see a live demo on LangChain and its latest multimodal applications. I'll let maybe Alex can give a little preview of this in a minute, but if this is interesting to you, you can RSVP at that short link. I'll put that on the chat in a minute, so you can just click to RSVP. You could also take a photo or a screenshot of that QR code. That'll take you to the same place, and we hope to see you Monday. Getting back to today's topic, we'd love for you to participate in the discussion throughout the session. There's a Zoom Q&A button at the bottom of your console. We also have a mission statement to answer all the questions that come in. It could be tough based on how many registrants we have, but as long as you log in with your name and email address, we will get to your question either today during the session, during the live Q&A at the end, or via email. So keep those questions coming throughout. We will get to you as long as it's not an anonymous question. We don't answer the anonymous questions. We would also love for you to try out the technology that we're going to be showing off today. In fact, anyone who tries it today is going to be entered into a raffle. Chance to win either new AirPods Pros or Meta's new Ray-Bans, the smart glasses. It's your choice. If you're the winner, you can choose one or the other. All you need to do is visit that link that's on your screen. It's the MySQL.co Claude 3 raffle, or MSQL, I should say. I'll put that link in the chat in a second. All you need to do is log in from that link. SingleStore, if you have an existing SingleStore account, awesome, just log into it. If you don't, just sign up. It's very, very quick and easy. We've had a free trial for years, but just in the past few weeks, we even now have a completely free shared tier, which we can tell you a little more about. So there's that link, log in, and I will announce the raffle winner at the end of today's session. Quick introduction for our speaker. Alex Peng is a growth engineer at SingleStore. His formal training was from the Stanford Computer Science program. He has expertise in big data, machine learning, and AI. He has become a regular speaker at our weekly webinars. Welcome, Alex. The floor is yours.
Cool. Thanks, Matt, for the intro. And yeah, just like Matt mentioned, we will be doing a webinar on using LangChain for text and image data, chatting with text and image data. Today, actually, we're using one of LangChain's competitor libraries, I guess, Llama Index. Thankfully, if you're using SingleStore, not to worry, we're integrated into both LangChain and Llama Index. But just to flag that for today, we're going to be working with Llama Index, which is not LangChain. But before we get into any of that, I wanted to talk a bit about some of the emerging architecture that we're seeing for LLM applications today. Now, for those of you here that are already sort of familiar with this landscape, a lot of this might sound familiar to you, but I just want to make sure we're all on the same kind of level playing field before we kind of get into the weeds of things. So really, the dominant architecture that we've seen for augmenting LLMs with information that they haven't been pre-trained on is retrieval augmented generation. And this is essentially a process where we take the user's query to any LLM. So say, for example, you're typing something to ChatGPT, that's going to be your question or your prompt. We pass that into your GenAI application or your kind of GenAI infrastructure or data stack. And then using that in some way, we actually pull out the relevant information. So for example, your company data or some image data that you'd like to look at or some text snippets that you'd like to look at. And I wanted to just dive a little deeper into what we mean by actually pull that out and how we actually transform that prompt into information that we're interested in. But just zooming out a little bit first, the AI stack architecture, if we've seen it evolve over the last 2 years or so, has really kind of crystallized into three main layers, right? Obviously, at the top layer, we have the UI. So that's going to be the way that you actually interact with these models. If you're working if you're interacting with these models through a SaaS application or through a consumer application like ChatGPT, you're going to be interacting with it through UI. At the next layer down, we have the API connectors that actually hook up the LLMs and the databases to the actual UI, to where consumers and users are actually reaching these services, right? If you're a developer, you're going to be much more familiar with the API layer. And that's going to be where like I just said, we're going to actually be able to talk to these LLMs. And then finally, at the bottommost layer, we have our contextual data store. And so obviously, this kind of segment has exploded over the last 2 years. We here at SingleStore have our own thesis. We believe that your data store should not be segmented and fragmented across, a proprietary and specialized vector store and your relational database, but instead that should be coalesced into one that simplifies your data access policies, that simplifies data governance, that simplifies multi-cloud tenancy, all of these things. But that's the last and final layer that we've been seeing in this emerging AI stack architecture. Zooming in a little deeper into the contextual data layer, obviously, I'm going to keep this at a high level because we're going to be getting into kind of more applications of the contextual data layer. But your contextual data layer is going to need to be able to store a number of different data types, essentially. Obviously, we have anything from streaming data to unstructured data, like we're going to be working with today, all the way to like structured data, tabular data. And we're going to want to be able to translate between these different kind of data modalities. Like, for example, if we have a complex and rich PDF that we'd like to examine, and it happens to contain tables and images, we may want to define some structured data format for parsing all of these images in this PDF. And that's where LLMs can actually come in. Before we talk about LLMs at all, though, we kind of have to think about how it is that LLMs actually interpret and process the data that's given to them. And that's through this process called vectorization. Essentially, the way that LLMs perform inference, or they actually run on your prompt or your images that you're interested in, is that you actually have to retrieve those images or prompts first before you can put them into the actual query that the LM actually runs over, right? And so when we vectorize our data, we're actually processing that data into a format that is easily searchable over after we process it, right? That's going to be data, anything from like proprietary company data to maybe like a couple of gigabytes of like the Wikipedia articles that you're interested in. And so just at a high level, the things that you want to consider vectorizing are going to be that unstructured data, right? The data that you're most interested in processing with your LLMs. You're probably going to want to be a little more careful with vectorizing data that requires special access or vectorizing sensitive information, as that's going to require additional considerations of like data access. Finally, just probably the reason that everyone is here today, obviously we've seen an explosion of multimodal LLMs, and multimodal essentially means that LLMs are able to reason not just over text like kind of the original GPT 3.5, but they're actually able to take in their query all of these different image types. Now we're seeing audio, we're seeing video, we're seeing obviously text alongside these images, and the LLMs are able to reason across these new data types surprisingly well. On the left here, you see a screen grab from the Google Gemini demo, which came out a few months ago, and we actually have a webinar on that as well. But today we're actually going to be talking about Claude, and specifically Claude 3, right? Claude 3 is Anthropic's newest multimodal LLM. Anthropic is sort of a emerging competitor to OpenAI that we've seen kind of come out with state-of-the-art models that are on par, and as you'll see, actually beating OpenAI at their own benchmarks, right? Which is really exciting, and at a price that's at or less what OpenAI is charging for their APIs, right? I'm going to take a quick aside here and just talk a little bit about multimodal embeddings. It's actually not going to be super relevant to what we're doing today because we're kind of sidestepping it, but embeddings are essentially a synonym for vectorization, right? And like I mentioned before with vectorization, we are going to be vectorizing any number of different data types, right? Traditionally, we're going to be just embedding text, right? That's kind of the first forms of vectorization that came out. And then kind of as these multimodal LLMs got more and more popular, we saw the rising popularity of a lot of these multimodal embedding models that allow us to run a single embedding model or vectorizing model over many different data types. In this case, though, we're actually in the demo today that we're going to be looking at, we're actually not going to be vectorizing our multimodal data, but instead we're going to be doing a different approach, which you kind of, with a lot of these things, you need to be testing it against your own proprietary data. You need to be testing these different approaches and benchmarking them, but we're going to be taking a different approach that's often a little simpler to implement kind of on first pass, which is essentially not taking a multimodal embedding model on your images that you'd like to be searching over, but instead using a multimodal LLM, which can take images as inputs and having it describe that image and embedding that text description, right? That's going to be another kind of alternative path that you can take over multimodal RAG. Obviously, you know, there's a big landscape of multimodal LLMs today. We're specifically interested in Claude 3, but there's kind of the most state-of-the-art ones, including, you know, GPT-4 Vision, you know, Google Gemini, and then obviously at the other end we have open source models, which we won't be getting as much into today, but those are going to include, you know, like Lava 13 billion, the Lava 13 billion parameter model, or the kind of adept model that recently came out called Fuyu, and which is an 8 billion parameter model. And the key question to ask here is really when you're deciding between these different levels of parameter counts for your multimodal models, you really don't want to kind of overkill on parameter count. So for these closed source models, they're usually much higher parameter count. Open source models are much lower parameter count. You don't want to expend additional unnecessary compute on your tasks. So again, you know, something that I've been really advocating for in all of these webinars, and something that each one of you kind of implementing this within your own company and within your own kind of data models and data stacks, you're going to want to benchmark these different approaches against, you're going to want to come up with a robust benchmark that you actually benchmark these different approaches against. And so that way you can evaluate the performance and make sure you're not overpaying. Finally, just a little bit about SingleStore and the kind of database that we think is best for these multimodal use cases. SingleStore is a database to transact, analyze, and contextualize in real time. We are for on-prem, cloud, and hybrid environments. We're multi-cloud. We're on GCP, AWS, Microsoft Azure. We have we have all the capabilities that you need to support these Gen AI workflows working with vectorized data. We have obviously support for vector data types, and we have traditional kind of relational database strengths. Like, for example, we can work row-based or in columnar environments. Just some quick stats on SingleStore as a database. I'm just going to skip over this really quickly because we do have a lot of code to get through. Let's see. Okay, great. Let's get into the code demo today. So let's see here. Pause this really quickly. Great. Okay, so if you're following along here, obviously, we're going to be working with Claude 3 today in Llama Index. But before you kind of do anything here, you're going to want a database to actually store your image or text or multimodal data in. And so if you actually go to singlestore.com/cloud trial, you can actually sign up and use our new SingleStore free shared tier, which allows you to get up and running with an enterprise grade database compatible with kind of these Gen AI data types really quickly, right? So you're just going to go ahead and enter, some of your details here, and then I'm going to actually show everyone really quickly. Once you have finished signing up here, you're actually going to end up in a page that looks much like this. And no worries if you're unable to follow along or if I'm moving a little too quickly here. We're actually going to be sharing out not just the recording of this video, but also the code used in our notebook. But after you've signed up on the cloud trial, you can actually go ahead and create your first group. And once you click that, that's going to be right here on this left tab here under Add Group. You can actually spin up your first starter workspace, and that's going to be on that free shared tier and allow you to kind of get up and running as soon as possible. And then once you do have that workspace, you can actually start prototyping Gen AI applications right within SingleStore. So today we're actually going to be working within SingleStore notebooks, which allows you this really cool capability to essentially have your Python code talk directly to your SingleStore database, right? So in this case, you'll actually get access to the notebook, and so you'll be able to import it directly into your SingleStore database. That's going to just look like going into your SingleStore notebooks. See, clicking into one of these notebook categories here, and then importing a notebook from a file. Or obviously, you can get started with one of our templates. We actually have a really cool template area called SingleStore Spaces, which shares out a lot of the demos that we've shown over the last few months for how to just really get up and running quickly on SingleStore with some of these Gen AI workflows. Great. Okay. Anyway, I know everyone's itching to see the code, so we'll just get it right into this. Some parts here I'll run live, but just due to some like environment constraints with like the API keys, we're not going to be able to see everything live. But I will walk through step by step how it's all done, so you're able to replicate it exactly at home. Great. Okay, so just getting quickly into our Claude 3 Multimodal Cookbook. I'm just going to give a quick overview of what we're going to be doing here today. First, we're going to be, like I mentioned earlier, we're going to be working with Llama Index, which is a data library, a Gen AI data library for ingesting, querying, and structuring your data that you would like to use with LLMs. The Llama Index is super cool. We've done a lot of great work with the CEO of Llama Index, Jerry Liu, and they've made essentially a really great library for connecting between your contextual data layers and your preferred LLM providers. So we're going to be using the Llama Index integrations for Anthropic, which is the company that makes Claude, and SingleStore. So great. Obviously, you're going to want to also set your API keys. In this case, we're actually going to be using the Anthropic and OpenAI API keys. That's because we're going to be using Claude for the LLM, and you'll see very quickly we'll also be using the OpenAI embedding function. That's actually one really great kind of strength of these GenAI libraries, Python libraries, like LlamaIndex. They actually make it super easy to kind of mix and match on the LLMs, embedding providers, and data sources that you'd like to use on your apps. And they also make it super easy to benchmark and evaluate each of those providers, right? So that's a really great way to make sure that you're kind of operating at the optimum of, not overpaying for compute, not overpaying for storage, and also kind of using the best possible models and storage solutions for your use case. Great. So let's see here. Actually, I'm going to pause really quickly and just make sure the API keys are working. And if you're able to see my screen here, you'll see I'm starting to install some of these libraries. And these live demos are always a little scary. This is just to make sure that the API keys are correctly registering, and you kind of see that they are. Great. All right. And then in this case, we're actually going to be testing out some of the abilities of the multimodal capabilities of Claude 3. And in this case, we're using, so Claude 3 has 3 different model sizes. They have Opus, Sonnet, and Haiku. And that's in kind of decreasing order of model size and price. In this case, we're using the smallest model, which is actually still multimodal capable. And actually, this is just a side tangent. Claude 3 Haiku is actually shown to be thus far, the most efficient model in terms of price and performance on a number of different benchmarks. But we will see that in a little bit when we actually start looking at some of these benchmarks and actually having Claude reason over them. So first, we're just kind of taking a look at this image of just kind of describing a paper about inducing fine-grained evaluation capability in language models. This is just an example image. Obviously, hopefully everyone here can imagine how they can incorporate their own proprietary company data into these workflows. But this is, a very dense image. It's got, a number of different sections. It's got some like architecture diagrams. It's got, different like images kind of stuck in there. And so we're going to take the LlamaIndex directory reader. We're going to load in this image. We're going to initiate the multimodal model. And then we're actually going to have the model perform a task, which we're actually going to have it do it on the rest of our image set as well. But this is just to kind of see over a single image example. And here you can see the model is kind of describing how the image looks. It's got, it's got an understanding of the different sections that it contains. It's got, a summary of some of the findings that the image kind of reports on. And obviously, you can already imagine there's a lot of different optimization opportunities here. You can kind of fine tune the prompt. You can make sure the prompt works for your use case. You can define a structured format that you'd like it to adhere to. Like, for example, a JSON format. Maybe you'd like it to fill out a few different fields for you. let's take a look at a slightly more complex image. This is actually the Claude 3 this is a Claude 3 benchmark summary image showing kind of the performance of the new Claude 3 family of models against some of the state-of-the-art multimodal models that we've seen. So that's GPT-4, GPT 3.5, and obviously the Gemini family of models. And you can see the most expensive model that has just most recently been released by Anthropic, Opus, is actually beating all of these other models. But the model that we're using, Haiku, interestingly enough, is actually giving the best kind of price per performance. It's almost, you can see, reaching GPT-4 levels on a lot of these benchmarks, but it comes in at a much, much lower price per token on that API. So again, there's a lot of performance and a lot of cost savings yet to be squeezed out of these Gen AI workflows. Obviously, the kind of most traditional method or path is to take the most expensive possible model and then test that your workflow works on that. And once you get there, you obviously want to start working backwards to see if you can squeeze or if you can get to an acceptable level of performance. And you oftentimes will, because of how good these models are getting, if you can get to an acceptable level of performance with a smaller model that's cheaper to run. So again, we can have it describe this image as an alternative text. And you can see it's already got an understanding of the table here as well. It's comparing, Claude 3, Opus, Sonnet, Haiku against some of these other models. And now we're actually going to be going into kind of an example RAG workflow. And that's going to be, I'm going to start sharing my entire desktop here. And that's going to be, we're going to be working with, as an example, just some images from Wikipedia. These might be a little small here, but I'll just try to show these images off. You can see these are just some pictures of a Porsche Taycan. It's just an electric car that I happen to like that I'm going to be using as an example here. And we have some other images kind of sprinkled in here that are meant to kind of throw it off. Like there's a Rivian in here. There's an Amazon delivery truck. There's there's a Kia electric EV in here. There's kind of an older vehicle in here. What we're going to be doing is we're actually going to be performing RAG over this data set of images. So we're going to be asking, the Claude 3 model to tell us about the Porsche vehicle specifically from this kind of data set of kind of a mixed data set of different vehicles. And the hope is that, using these RAG techniques that we've talked about, we can actually get respectable performance out of some of these new models that are coming out from Anthropic. Great. So we're just going to be running this here. And that's going to finish downloading. We're just going to clear the cell output. I'm actually going to very quickly just confirm that the mixed images small. I'm just confirming that the files have downloaded correctly, and you can see that they have. And let's take a look here. Let's see. And now running this code, you can kind of see that we're starting to process these images. And what this processing step essentially entails is that we're going to be processing each image, having the Claude 3 model actually go in and describe the image. And we're going to be appending that text response or that text description to a node. And nodes are, at a high level, essentially the way that Llama Index stores chunks of information. So once we have a list of nodes of these image descriptions, we're going to collate it into and I'll talk about this error in just a second. We're going to collate it into a vector store index. And the error that we just scrolled past is actually a rate limiting error. That's going to be something that you're going that's something that you will need to make sure that you are like sleeping in your code enough, or delaying or making your code wait enough before you hit the Anthropic API again, to make sure that you're able to actually process all that data. For the sake of time today, I'm just going to leave that as an exercise to the watcher. But now we get into the actual initialization and ingesting of the SingleStore database. And that's where it's really cool to be using a SingleStore starter workspace, or whatever workspace kind of best fits your needs. Because when we use SingleStore notebooks, we can actually kind of get all of our connection details and information automatically populated for us. And so if you're running this notebook, for this part, you're actually going to be able to kind of get up and running right off the bat. And so running this code, we're essentially embedding some of our we're embedding the text descriptions that we've used for the text descriptions that we've generated using Claude 3, and then inserting that into the database. And that gives us kind of a corpus of information from which to actually perform retrieval augmented generation over. Looks like I'm getting some issues with the API key here, so I'm just going to quickly swap in a fresh API key. Let's see here. Second here. And this is always the issue with live demos. Great. Okay. So what I've just done is I've just gone in and swapped in a new API key at the very top, where we're defining the API keys in the environment. And let's take a look here. Strange. 1 second. So just for the sake of time, as I am seeing a good amount of questions, and I'm anticipating that we'll be needing to answer a decent number of questions in the last sort of 25 minutes of this webinar, I'm going to we'll have sent out a fixed version of this notebook. It appears that we're running into some API key issues here. The code itself should all be working. If you use your own Anthropic and OpenAI API keys, that should work for all of the code that we've looked at so far. I'm just going to walk quickly through the rest of the code and kind of explain the kind of intended behavior here. Essentially, what we're doing is we're going to be populating a vector store. And in this step, we do the embedding, ingesting and populating of the database that we end up spinning up to work with all of this data. And then in this case, we're using the OpenAI embedding model to actually do just text-only embedding. We're not using a multimodal embedding model, as we talked about before. And then LlamaIndex has this abstraction layer called a storage context, which is going to take as an argument our vector store. And finally, we're going to be creating what LlamaIndex has as an abstraction, this vector store index, which allows you to actually finally chat with your data. And you'll see LlamaIndex has this really cool ability to essentially turn any vector store index into a query engine. And that allows you to kind of ask any question you'd like of your data. And finally, if we run this now, we're going to get an error as the kind of vector store index hasn't initialized properly. But from my previous testing, we've had this question, tell me more about the Porsche. And then you can see, at first it kind of gives, and this is maybe instructive of how to actually work with LLMs in production environments. It kind of gives this answer of like, unfortunately, I can't directly reference the provided context, but it actually ends up able to describe the car that we would like it to describe, right? And so that's where considerations for enforcing structured outputs for the LLM, actually sanity checking LLM responses. One cool approach that I've seen a lot of production level workflows use is using an LLM to check the work of another LLM. But yeah, that's kind of the very high level of all of our code demo today. Matt, Akmal, I know we ran into some hiccups here, so I'm happy to answer questions about those, but
All good. Yeah, we've got definitely some questions here in the chat. And before I get into them, Akmal, I know you've been answering dozens as we've gone. Is there any you want to bring to Alex or voice for the community?
I think general questions about this particular vendor's offering versus others. This comes up frequently. I think people are sometimes looking for kind of insights. What's the best technology? What's the best model? What's the best LLM for a problem that I have? And this might be good for this particular use case, but what about others? And I think for this specific one, Alex, I think there's a couple of questions there about, does it handle PDFs, for example? From my reading of the Claude website, it doesn't. But maybe I'm wrong. I mean, the images you've shown there, yes, it can handle those. But what about specific sort of documents that you might want to scan? I think you've got OCR somewhere in the title of your talk, which implies that it does work. But what do I know?
yeah, that's a really good question, actually. And I'd encourage everyone here to actually look at the Claude kind of the consumer side of their LLM, which is kind of just their ChatGPT equivalent. You'll notice that you're actually able to insert PDFs here and upload them for the LLM to chat with. That's not because the LLM is able to directly chat with the PDFs or directly support the PDFs, but instead what it does is it just takes the PDFs in raw plain text format, and then it just has such a large context window that you're able to append it to the top of your prompt, and it's able to reason over the entire PDF. Another approach that I've seen is, and actually this is something that LlamaIndex supports, is using some sort of pre-processing on a PDF to actually extract and embed the text snippets inside the PDF, and then asking the LLM to answer questions over it. That's another great approach, especially if you're dealing with especially large PDFs. Though, as we've seen the kind of increasing advancement of these LLMs, we've seen context windows get bigger and bigger, and they're better and better able to handle long context, which is why kind of Claude's approach is to just take a plain text PDF, and just append it in text form at the top.
Good stuff.
I
I
think one of
see
the
one
nice things.
question. Go ahead.
Oh, sorry to interrupt you there, Matt. I was just going to say that we had a while back, I think it was last year actually, one of our customers came to us and they were interested because they use OCR to scan documents. And unfortunately, there's errors in that process. Maybe the technology isn't up to the job. I don't know what kind of scanning technology they use, but they were kind of interested to see, would something like an LLM be better? And I suggested to them, look at LangChain because they was using it at the time. And it's got some great tooling available that you can use to work with PDFs, chunk them up, store them, and you get a very good representation, and the error rate is much reduced. So I think the customer went away and had a look at that. I didn't follow up with that, unfortunately, but I think that's one great way that you can deal with PDF documents, which I know, images and video and all this kind of stuff is great. It's great we're going down the multimodal route, but I think historically we've tended to work with text a lot. Okay, so still it's going to be very important. Companies deal with enormous amounts and volumes of text data just on that. So that could be a great way to, apply this technology.
Cool. I see one question here from Nathan Law asking to compare OpenAI Clip versus Meta Dino V2. I know before the webinar started, we were talking about OpenAI Clip. I think you both have experience with it. I don't know if either of you have tried the Meta version.
Yeah, so that's a really good question. Actually, it's a bit outside of the scope of the webinar. To be completely honest, I don't have direct experience with the Meta multimodal embedding model. In this specific case, we actually did not use any multimodal embedding models. We used the kind of alternative approach of just like creating a text description using a multimodal LLM and then using a text embedding model on that text description. I would just say the answer is always going to be benchmarking. So I think the Meta multimodal model is an open source model, if I'm not mistaken. And so there's a lot of great approaches to evaluating open source embedding models on your proprietary data. Just off the top of my head, I'm pretty sure Llama Index supports this actually. There's an evaluation pipeline function in Llama Index for kind of evaluating different embedding models and their kind of retrieval accuracy over your proprietary data set. So I would just recommend making sure it works for your own personal data.
Yeah, the only thing I could say about Clip is that I used it a little bit. That's for the webinar that we've got sometime in the near future. I think 11th, is it, Matt?
Yeah, and that's a good response. There's been some questions here. Does Claude work with videos as well?
Yeah.
So I'm gonna post your upcoming webinar. I know you're not working with Claude, you're working with
I'm doing
OpenAI
Clip.
But
Yeah, I mean, what I could say about Clip is that I was very impressed. It's kind of one of these zero shot type technologies in the sense that, I mean, it's got a bunch of knowledge and stuff that it knows about. And basically, you're just giving it things and then you can ask some questions. And it does a pretty good job, actually. So that, I'm very pleased with that without having to spend a lot of time and effort working with something else. And this is just using the free open source kind of version, what's on GitHub that OpenAI put up there. And it's awesome. Looks great.
good stuff. I see there's a couple different questions about just like file types. I know we talked about videos. I see some questions about images, tables in the PDF. What if the PDF has different layouts inside of it? And Alex, just help me understand this a little bit because I remember when I read Jerry Liu's original tweet, on that image that he was talking about, it looked like a really complex image. It had images, it had handwritten language, it had different colors, it had boxes, and like a really graphically designed layout. And he said, Claude can figure all this out. It's really excellent at synthesizing what's going on in this image. And so I guess my question is is that specific to only if that's a certain type of file? Like if that same type of layout, highly designed layout was in a PDF, it wouldn't be as good?
Yeah, that's a really good question. There's a number of different pieces to this sort of use case. First, like the the performance that you're going to see on like Twitter demos, or even just to be completely honest, like in a kind of well curated demo or webinar, like some of the demos that we put out, it's going to be sort of a high watermark or a standard that you're going to try to hit with your proprietary data, but it's going to take a lot more work to actually get the data processing kind of pipeline and getting kind of all the different prompts properly tuned for your proprietary data, evaluating different model sizes and different embedding models. It's going to take a lot of different steps to actually get to that final product, right? I think in the case of Jerry's demo, what he's doing is he's actually taking, he's not actually doing the plain, like using the plain text representation of the PDF and appending that to the LLM's prompt, but he's actually just taking kind of a screenshot of the PDF and then having Claude 3 kind of reason over it. And, that's an expensive approach because images actually use a lot more tokens than text does, especially high resolution images. If you'd like it to be able to kind of like pull out the very like pull out smaller text captions and the like from your images. So that's like kind of the most expensive possible approach, which is like just high resolution images of all your PDFs and then having like the most expensive possible model run over it. If you do that, probably everything's going to work. It's just your bill is going to be, through the roof. And so as always, like the bridge from kind of demo to actual production level where the costs are reasonable and your performance is reasonable, that's going to be a kind of a tougher bridge to cross.
Good stuff. I see this question from Aish. I don't know the answer to this. Is it possible to input audio as of now into any of the LLMs that's out there? I know I've read a lot of the news on like OpenAI's audio capabilities, but like they're in testing version and not really widely available. I've also heard I've wanted to do something with is it 11 Labs? I think they really focus on audio. Do you have any idea, Alex? Have you done anything with that?
Yeah, that's a really great question, actually. So, as far as I know, audio and video, just to cover kind of both of those bases, those are sort of emerging data types for these multimodal LLMs. The state-of-the-art LLMs, like for example, Gemini, I know for example has this capability for sure. Like they have audio input as a very limited release. Like for example, in their demo, in the Gemini demo, they showed audio input, actually just like someone talking using their voice to the LLM. There are smaller open source LLMs that can take audio as an input. And I would just kind of encourage everyone to look at the very vibrant like GitHub community around open source LLMs. That's a really great way to kind of understand what's at the bleeding edge of this technology. But in general, audio and video is likely not going to be released to like those capabilities in state-of-the-art LLMs, likely not going to be released, at least for the next month or so. But things move so fast in this space that it's really hard to say.
Good stuff. I see Nicholas has a very interesting question here. How good is this technology for invoice OCR? Can the data be extracted and exported in a structured format? This is top of mind for me because I just, in the United States, taxes are coming due. I just went through TurboTax, and in that I have to like upload all these documents, upload the W-2, upload investment statements, whatever. And Intuit is pretty good at this. It does make some errors occasionally, and it tells you to like check it all over. And I know they're also working with certain templates, like the W-2 is always the same PDF. It's always in the same format or whatever. But I wonder what either of you would say if you feel like the OCR you've seen, especially in these newer models, are they like production ready? Could this actually be put into an accounting or a insurance use case?
Yeah. So for that use case specifically, I've seen a lot of actually pretty great like kind of B2B and B2C applications being developed on top of APIs for like the specific use case of doing your taxes for you, essentially. Um, I personally, I would actually look at those solutions first and see if like the pricing on those is like reasonable at all before trying to build my own kind of like bespoke solution. I know, like just off the top of my head, there's this company called TaxGPT which does something very similar to what I think has been described here. And I say that because it is actually a very involved process, especially when you're working with sensitive information that you really want to make sure you get right. It is a very involved process to make sure that's at like almost a human level, right? Because, I imagine, Nick, if you want like, an automated way to do this, there's probably like hundreds, if not thousands of documents. Otherwise, you would just kind of suck it up and just do it manually, right? And you'd be, that's the way you'd be most sure that it's being done right if you're doing it by hand, right? If you have an AI do it, there is the benefit that, it can parse over thousands, tens of thousands of documents. But in especially a case where you really don't want to get the numbers wrong, or the IRS is going to come for you, it's worth considering kind of applications that already have been built on top of the API layer that you could consider using.
Good stuff. I think we have time for a couple more questions before we announce the raffle winner. Akmal, I know you've been typing furiously. Is there any questions you see? And same for you, Alex. Any questions you see unanswered that you want to speak to?
Yeah, I was just answering something from Mitchell here. Was asking, can I use this to analyze multiple PDFs or research reports, hundreds of papers? Yes, you could. In actual fact, I think in the spaces in Gallery, there is an example that we have from AWS, Bedrock, which actually loads a bunch of documents from them. That's something they provided to us. So that's an example of how you could actually read in multiple PDF documents. I think the example they gave, it's less than a dozen, I think. But technically, there's no limit. You could extend that to hundreds of documents if you want. And once it's stored in your database system, of course, then it's very easy. You could search it however you want. I mean, that's one way you could do it. Okay, there are other solutions, but
Good stuff. What about you, Alex? Do you see anything unanswered that you want to get to before we get to the raffle winner and everything?
Yeah. So let's see. I got an answer or a question from Shrikar, who asks, can we directly convert the extracted values into a structured CSV and export them, similar to how Gemini has functionality to export answers to Google Sheets? Really great question. And yes, actually. So Llama Index has the ability to actually define your own structured data model. So you can define a custom class with custom fields, and you can pass that as an argument to a multimodal LLM when it's running over, or when it's inferring over a text and image data, and you can have it fill out those fields for you, right? And then once you have those fields filled out, you can export them to a CSV, you can export them to an Excel file, you can save them somewhere. But yes, actually, that's actually one strength of Llama Index, is it makes it pretty easy to define in code, a kind of a structured query or structured output format that you'd like the LLM to adhere to. Define those custom fields that you're interested in extracting from your from your image or like PDF data, and then actually like being able to work with that output.
Great. Akmal, I'll give you, before I announce the raffle winner, give you one last chance. Any questions that you see that you want to make sure you answer before we wrap up today? Akmal, you on mute? Did we lose Akmal?
Sorry, my wife just arrived. I was
Oh, no
chatting with her. I
worries.
didn't want a conversation to go out to the rest of the world.
Oh, no worries.
No, it's okay. I was just going to say resources. So some questions about notebooks and resources. There's a couple of links I think we can send out to attendees, Matt. So that one that I referenced about Bedrock and AWS with the PDF docs, I'll dig that up and send that to you so you can send that out as part of the email. I think that'd be great.
Sounds good. Sounds good. Yes. And on that note, I put it in the chat just a minute ago. If you feel like there's something burning that you want to ask, we got the hello@singlestore.com email address. We can follow up with you. Or if you want to book time to talk to one of our solutions engineers, I've also put a calendar link in the chat so you can do that. Let's go ahead and wrap up. Announce the raffle winner. One note before I announce that winner. Reminder, if you like today's topic and you want to go further with multimodal, Alex is going to be presenting on Monday. He's got a busy few days, but he's going to be presenting LangChain for multimodal, chatting with text and image data. Come check out his demo. I just put the link in the chat once again. Hopefully you RSVP and we'll see you there. The announcement you've been waiting for is today's raffle winner is Vijay Kukreja, VP of Electronic Trading Technology at Bank of America, New York City. Congrats, Vijay.
Well,
Thanks for joining. If that's not you, don't give up. We're going to announce one more AirPods winner or Meta Ray-Bans winner by the end of the day to anyone who has tried out today's demo. You can sign up with the same link that we gave at the beginning of the session. I'll post it in the chat one more time. But keep an eye out on your email. We're going to end up sending out this notebook, this video recording. Once again, all you need to do to be eligible for this raffle is sign up for that link. Thank you, Alex, for awesome presentation and demo. Thank you, Akmal, for QA as usual. And thank you to our audience for joining us. Have a great rest of your day, everyone.
Thanks, everyone.
Bye.